All right, so let's try this example. We are finding the derivative of g, and we have to use chain rule in this case, but we also have to use other rules. So let's digest this problem and see which rules do we need to use, and hopefully we lay down a strategy for us to find the derivative of this. So what I see here is this function raised to this function multiplied by another function, right? This function is the same thing, a function raised to a function. So what I'm trying to show you is that there is the product of two functions, right? The first function and the second function. So since we're finding the derivative of a product, even though there's inside function and inside function, right? We're overall the bigger picture, the big picture is that it's a product of two functions. Since you have a product of two functions and you're trying to find the derivative of this, then we'll use the power rule. That'll be the product rule, right? Product rule. So we're gonna go ahead and set it up. Okay. So if you see here, we set up the plan, right? This is our plan, right? We use the product rule. What we're doing here is so that we don't have to do everything in one line. We send like little promises, notes, right? We're gonna come back and do the derivative of those. Now here, to do the derivative of this, we consider what do we need to do the derivative of? Well, this is a function inside another function, right? So the outer function happens to be the power function, and the inside function happens to be just a polynomial. But when we do that, to find the derivative, we use the general power rule, which states to bring down the power, leave the inside as it is, take away 1 from the power, and multiply by the derivative of the inside. So let's go ahead and do that. So bring down the power, leave the inside, okay, and then we're gonna say leave the inside as it is, take away 1 from the power, and then multiply by the derivative of the inside, right? That's what we're trying to do for this first derivative. So what's the inside? 7x plus 6, 7x plus 6. So we'll come back and just finish up the 7x plus 6 prime. But let's go ahead and rewrite everything else. And now let's go ahead and do the derivative of this one. So let's try again by using the general power rule, bring down the power, leave the inside as it is, take away 1 from the power, and then multiply by the derivative of the inside. What is the inside in this case? 3x plus 2. All right, and so again, we left these promise notes that we're going to come back and do the derivative of those. So let's go ahead and do that. What's the derivative of 7x plus 6? Well, the derivative of 7x is 7. The derivative of a constant like 6 is 0. So 7 plus 0 is 7. And then we carry everything else. The derivative of 3x plus 2, the derivative of 3x is 3, plus the derivative of a constant is, the derivative of constant is 0. So 3 plus 0 is 3. And that's your derivative, right? So we're going to go ahead and simplify by just multiplying these two together, and put them in the front. So 12 times 7 is 84. And carry the rest of it. 26 times 3 is 78. And there you go, right? So this is the derivative of g. There you go. And that's as far as we have to go, right? So the important part of this problem, or the point of this, is that we often going to use different rules to come up with a derivative. So, but that means that we now have opened the door to more abstract functions, right? And we have almost covered every single type of functions that we are gonna see in this class, right? So I hope you guys found this helpful. Please let me know if you have any questions.